Hey guys, this is Eddie. Welcome to another maths tutorial. Today we're going to work on complex numbers a little bit more. So let's define a complex number. Let's call this z equals, let's say, 3 plus 2i. Okay, 3 plus 2i, and let's draw this complex number on an Argand diagram. So oh, by the way, I've just discovered you can draw straight lines by pressing shift. So, sorry guys, I'm a bit of an idiot. So you got 0 in the middle, and let's go to the 3 units to the right on the real plane, and then 2 units up on the imaginary plane. 2 units up, and this is our complex number z. And if we draw a straight line from Z to the origin, okay, the angle that this straight line makes with the horizontal, this angle here, theta, is what we call the argument of Z. So theta equals the argument of Z. And in order to find this angle, what I'm going to do is I'm going to draw a bigger triangle so you can see what you have to do. So this is the triangle that represents what we have over here. And we got theta here, and we have 3 units on the x-axis and 2 units on the y-axis. Now, if you guys remember the trigonometry ratios, we got the opposite side, the adjacent side, and the ratio that we're going to use is tangent, because tan theta equals opposite over adjacent. Okay, and let's substitute the numbers in. So we got 2 over 3, so tan theta equals 2 over 3, theta equals inverse tan 2 over 3, and let's put that in the calculator. So put it in degrees, inverse tan 2 over 3, and you get 33.69 degrees. Okay, 33.69 degrees. Okay, so that is called the argument of Z, and we can also write it using this notation: argument arg bracket Z equals 33.69. And for those of you who know about radians already, what you can also do is you can put the calculator on radians and repeat that same calculation. So arctan 2 over 3, and you get the answer in radians, which is 0.588. So, or 0.588 radians. Okay, so I will give you another example question, and you can have a go and see if you can do it. So let Z equal 4 plus 5i. Find the argument of Z. Okay, so have a go at it and come back when you're done. So here are the answers. You draw a quick diagram with the complex number Z at this point here, and draw a line to the origin, and the angle that this line makes with the positive x-axis, theta. To find that angle, use the tangent ratio, substitute the numbers in for opposite and adjacent, do the inverse tan, and you end up with theta equals 0.896 radians or 51.34 degrees. Okay, so now let us do a question where Z is in quadrant 2. So if you're not familiar with that terminology, basically this is quadrant 1, and this is quadrant 2, and this is quadrant 3, and this is quadrant 4. So let's try a problem in quadrant 2. So I'm gonna let Z equal to -3 plus 2i, and we're going to find the argument of Z. So feel free to have a go at it first and then watch the video if you like. Otherwise, I will teach you guys how to do it right now. So let's draw a Argand diagram. So this time have to leave a bit of space on the left because 0 is here. On the real plane, we're going to move 3 units to the left, and we're going to go 2 units up. And this is our Z, this is our complex number. Now if you draw a line to the origin, the argument of Z is the angle between this line and the positive x-axis. The argument of Z is here. Okay, but using inverse tan, because our right angle triangle is over here, what you're going to do is you're going to find, sorry, let me draw that properly. So because our right angle triangle is over here, and using inverse tan, we got the opposite, the adjacent, and let's call this theta 2. What you're going to do is you're going to find theta 2 using inverse tan. And then what you're going to do is you're going to go 180 degrees minus theta 2, which will give you theta. Okay, so if you want to have a go at that from this point onwards, have a go. Otherwise, I will show you the answer now. So we have tan of theta 2 is equal to opposite over adjacent. Okay, so substitute the numbers in. So we have opposite is 2 units and adjacent is 3 units. So theta 2 is equal to inverse tan opposite over adjacent, so 2 over 3. And then you get the answer, which is 33.69 degrees. Now because we want theta 1, or theta, so theta is equal to 180 degrees minus 33.69 degrees. So typing that in your calculator, it's 146.31 degrees. And if you want this answer in radians, you can also type in the calculator 146.31 degrees divided by 180 times pi, and that will give you the measurements in radians. If you're not sure how to convert between degrees and radians, you should have a look at our other video on radians and degrees conversion. But if you put in the calculator 146.31 divided by 180 times by pi, and you should get 2.55359 radians. So 2.553 radians. Okay, which should be correct because 180 degrees is equal to pi radians. And pi radians is 3.14 degrees, and 2.553 is a bit smaller than that. Okay, thanks for watching, guys. See you next time.